So what I'd like to do is I'd like to just finish with random questions.
Sure.
So um, really what I've done is I was sort of asking the people on Patreon, what would they like to see from these interviews and things like that. And it sounded like they'd like to have a little bit more input on what to put into the what goes into the questions here. And some questions could easily be worked into what we were doing, right? I mean, it was talking about comparisons to other gravitational theories. That's one of the sorts of things they were
Hmm.
asking about. Um, of course, the unfortunate part is after I posted on the posted that we were going to be doing this, and I'd like to get any questions they had for you. Nobody actually posted any, but
Okay.
I would like to start just asking these random questions a little bit, and I think they'd make a good sort of removable segment that I could put up onto like YouTube as an advertisement
Sure.
prior to actually finishing editing the podcast.
Hmm.
So let's just ask some. I'll just ask some random questions, and you can answer them to whatever detail you like. And some of them will probably include some of these things. I think some of the things you had to say were pretty interesting and could be repeated as well.
Sure.
Let's just start with the simplest ones, like your background. So you have a bachelor's, I understand, in physics.
Yes. I have a bachelor's degree, BSc, but it's actually, Jim, it's not in physics. It's in biology and psychology at York
Okay.
University, and I started a plant ecology master's at one point and didn't go on with that. And eventually, after that, I went into the field of the origins of life in biology. Um, I did some papers on that, and I realized that there's certain factors that are holding that field back at the moment, and that it's basically been static for about 20 years at least. And I have some ideas about that, but that's then I got interested in physics from that point on.
Okay. Excellent. Let's see. Now, I actually have a student who comes in once a week, and we talk about origins of life stuff. So,
Oh yeah.
I mean, that's really interesting. Would you be willing to say one or two of the things that you think are keeping the field back, or is that something ultra secret?
No, it's
Okay.
not. It's not. Uh, Jim, origins of life is it's a field where I think there was a little bit more activity and new ideas back in the 90s. We had some, I don't know if you've heard of Gunter Vectorshäuser and people like that, some very strong individuals, and basically had the idea that life really evolved autotrophically. Uh, it built itself, but there's still a lot of people thinking that it's different chemicals arising from different sources that interact together in a kind of a random way to form more complex biomolecules. It simply can't happen that way. But if you look at it as a sort of I use the analogy of a growing molecular embryo. Every part of that molecular embryo, it things a particular chemical sequence is arriving or being formed in a specific spot. So it's in the spot where it can then react with uh, something else or another part of itself. And that's what my model, the origins of life, was based on. It's sort of like using the idea of metabolite channeling as well, that you can do a lot of stuff without enzymes at all. If you have molecules attached initially to a surface like a mineral surface, and it's most likely a pyrite surface. There's so many properties, optical properties of pyrite, uh, that can be used, and Helmut Tributsch in Germany, and his coworkers did some studies on that and found that pyrite was actually superior as a thing than the things that Vectorshäuser was talking about. They could solve the origins of life if they got onto this. What you really just need to do is take all the different possible uh, properties of iron sulfides and chiefly pyrite, and just subject it to different conditions, different atmospheres, different sources of, like, probably hydrogen or carbon monoxide, uh, and just but it's a vast, like, it's a pretty vast effort, right? You're looking for just the right conditions, but you got to start with the right chemicals and the right approach. But if a lab, or actually it'd be more than one lab, set onto it, they could solve the origins of life.
Okay, excellent. I'm always want to find out more about that. Mostly because a lot of it doesn't make any sense to me. So
It's
I
again, it's another area where people can just publish whatever and get taken seriously.
okay. All right. So, how long have you been working at the University of Toronto? Because I mean, here it says you're in the library, but I assume that's just an office address. An earlier paper that I don't have with me, and I keep looking around to find it, had a research center or something that you were associated
Yeah,
with.
yeah. I was at the Gerstein Science Information Center at the U of T, but guess what? That is actually the science library. They just put a fancy name on it. And I moved over. I was there from starting in 1983, and that was the good thing about working there. It used to be called the Science and Medicine Library. We have such a great science collection there. The papers I'm talking about relating to the early Lesage series, we've got all that stuff there. I mean, U of T Library is one of the best libraries in the world. It's got so much there. And then, but they moved me over to the other library that you saw in the most recent paper. And that's been interesting too, because that's also an excellent library, Robarts Library. And one of the bonus things there is I got to work in the Fisher Rare Books Library, which if you ever happen to visit Toronto, you should pop in and have a look at Fisher. It's just a gorgeous. We got like something like 800,000 or 1,000,000 volumes of old stuff there, and it was really a treat to be able to work in there. And it's a great staff over there, and it's been a really quite a change from working in the science library.
Okay, excellent. So I guess the question is, how did you get started publishing? Right. I mean,
Well,
as for a traditional physicist, right? Somebody who's
yeah,
gone through graduate school, you've got somebody who's sort of forcing you to publish when you're
yes.
25 or whatever. But how did you get started in publishing?
Well, it was very difficult, as you can imagine, because I'm just putting my stuff in under my own name. Essentially, I have an institution, but they're not really tracking me as to what I'm doing. Uh, and my first papers were on the origins of life, as I mentioned. And then I found that it was a lot harder to publish in physics journals. There's something different about the outlook. They're not. Again, I don't want to get into dumping on physics, the physics community too much, but it seems that they're definitely not as open-minded about new ideas as I would say in biology. It's just or geophysics. I mean, I get geophysics is pretty open to new conceptualizations, uh, and how do you have to keep sending your articles get rejected, and so many times, like I've got papers, so many papers that are sitting and not published because they were rejected, and I've moved on a little bit from where that was, and so oftentimes I'm trying to cobble together all the stuff that wasn't accepted to try to answer the new problems that have come along.
But you've still had a fairly good track record in publishing things, as far as I can see. I mean, you've
Oh,
got one every year, every 2 years or so, and that's pretty
yeah,
good.
yeah, yeah. I'm pretty persistent, I have to say, Jim. And also, I've learned one thing I learned about publishing is that if they say no, you just don't just like accept it as no. You just usually often there's you can reason with editors and and uh, make a case for yourself. I'd say again in physics, sometimes they just close the door and it's like, we don't really want to see you anymore. But in general, I would say in general, ex excluding some physics journals that just keep working on it and you can keep publishing. One thing I don't like to publish in the there's a lot of journals now where you can, pay for your work to appear. I don't really want to have my work in those type of journals. I do want to stay with the mainstream if I can.
Okay.
Some people have had to do that though to get their work published. They finally have to go into one of those journals to pay a couple $1,000s or whatever, or less maybe, to have their work appear. But it's a sad state of affairs. They shouldn't have to do that.
Well, I mean, they're often publishing fees anyway, right?
Mhm.
But yeah, I mean, it would be nice. These journals cost a lot, right?
Yeah,
And I guess working in a library, you definitely know that.
yeah,
So I mean, it would be nice if everything was free for the author, but
yeah,
it doesn't always work out that way.
yeah.
Actually,
Now
almost never. Hmm?
they put so much onto the author to do that, all the work is downloaded onto the author pretty much. Even suggesting the reviewers and such. I never liked that part. It shouldn't be why should it be the author's job to suggest reviewers? Shouldn't the editors know who to send things to? There's a general decline in the academic world that I've noticed over the last like 30 years or so. And I think it started with the introduction of the electronic journals. Frankly, uh, I think the world was different when we were in the print world, and not everything had moved over properly to this electronic world, except the profits for the journals publishers.
Yeah. I do have a story. It's not a great story, but it's a story. So about paying to publish. I've completely forgotten about this. When I was an undergraduate, I worked at a little game store, right? And one time, a physicist walked into the game store. Actually, more than one time. Somehow, I had physicists walk into my game store, but a physicist walked in, and I was, let's say 22, 23. I was not publishing anything, right? I was just working in a game store and going to school at night, right? That was all that was happening. And for some reason, I think a lot of people have this idea. I thought that, if you get published in a journal, they give you money, right? And this guy disabused me of that notion right away, right? He said, no, no, no. He said to me, no, you don't get paid money if you publish in the journal. You get to pay them money to publish in the journal.
Yeah, what happened to our world? Oh,
Um,
wow.
uh, and in some journals, the publishing fees are actually exorbitant. Again, I'm not
Mm,
going to use that word because I don't remember how to pronounce it. Yeah, the publishing fees are too large, right? Much too large.
mhm.
Okay, so I think that's enough of stuff that's going to get me into trouble. So let's see. I would like to ask you little bit. I think we got a pretty good idea in general from listening to how you talked about different things, but I would like to get a general idea about your sort of maybe a philosophy behind your approach or the general ideas you have about how to approach science, if you could.
Uh-huh. Okay, well, really, I really believe in what simpler is better, uh, Occam's razor all the way. Now, I do cut back to how is the universe, what universe do we want to live in? Do you want to live in a universe, a Big Bang universe, everything expanding, gradually stars too far away, you'll never see them again, and eventually everything is going to collapse and fade off into nothingness or crunch back in on itself, and or did you or would you rather live in a universe that is stable, it's always been here, uh, things are going to keep on more or less like they always have. You know, I think that uh, what's happened in physics, I have to say that it's a large part of this is due to a certain macho attitude towards physics. Uh, it's just there's just something that it's like guys always want to uh, impress with the next ridiculous idea, and then and there's not a free flow enough of ideas, uh, and just a sort of in, intellectual kind of uh, games being played all the time. Uh, and I don't think it was always like this in physics. I think that, let's say, things were going along more or less in a nice way when we had characters like Michael Faraday, we had Kelvin, we had Maxwell, and those type of guys. But things came apart in the 20th century, and I'm afraid Einstein was part of it. But really, the quantum mechanics people uh, did the rest, most of the rest of the job, and then finally the cosmologists got in and finished the job. But it's there's just a, a, what they sort of got away from is the idea of doing experiments and uh, basing things on things that actually are seen in the lab, and going more with all these different theoretical things where you now have pages and pages and pages of equations and papers uh, that first off don't make, you'd be kind of nuts to try to go through all those equations, and there's no confidence that they really lead you anywhere. And this goes again to the theories of quantum gravity and such. Um, so going back to simple approach to physics, geophysics too needs to address some things, um, and astrophysics as well, because we have got big problems in astrophysics. They're working with totally ridiculous models of what's generating the heat that we see in things such as white dwarfs, neutron stars, supermassive black holes. There's a way simpler thing to explain these energies, which I've described here in the Hubble luminosity and such. And by the way, this Hubble luminosity, this basic equation that this energy release is equal to the gravitational potential energy of an object times the Hubble constant. This can be tested, so it's not like I'm just uh, you know totally gone off on the idea side too. This thing can be tested. It's just hard to test. It seems to hold in some of these large objects, but other things can be causing those heating effects too, in like a neutron star. Exactly, we don't know exactly why a neutron star should be emitting so much energy. Um, we need to actually test this in the lab somehow, but then it gets to be so small. The amount of energy release is so small that it's really hard to measure it. So we need something in between. And I think the thing that's in between could be something like an icy asteroid that should have no other source of internal heating, right? Let's say there's no tidal forces there, is far away from Saturn or such, and we could do what we do on such an object like we did with the moon and just exactly measure how much heat is coming out of there. There should be none if it was if under normal expectations, but in my mechanism there will be some heat being produced inside there, and that so I really what I would like my basic message here, Jim, is to say, will people kindly think about my mechanism for a bit and how this thing can actually be tested one way or another, and to because it's fundamental. If I'm correct, it's a fundamental thing in geophysics, astrophysics, gravity, cosmology.
All right, excellent. And I think what we just said was this paper, Optical Gravity in the Graviton Space-Time, just came out in Optic. I don't know if they call it Optic Magazine. I mean,
Optique.
Optique.
Yes.
Obviously, it's from a German company. It's got a.
Mm.
I think it's a German company. So excellent. I want to thank you very much for this. Like I said, this part will come out as something separate, probably. I'm not sure if I'll leave it in the podcast, but I'll put this up on.
Sure.
I'll put this up on YouTube, and then I'll use it as an advertisement for the actual podcast, which will come out a little bit later. All
Wonderful.
Right? Okay.
Wonderful, Jim.
All right.
Thank you very much for giving me the opportunity to express my views.
Well, thank you for coming on. I mean, it's good. One of the things that happened without Randy is that Randy is the guy who is more turned on to all of the different things that are going on that aren't really right down the center in physics.
Yes. I heard some of the ones you did with Randy, and he's a really interesting guy. I'm sorry to hear about that.
It was a surprise. It was not something. It's not something I was expecting, but I really do want to have. I really do want this to go a little bit farther than what I'd see. So, I mean, the way I do things is I just, log on, look through the archive, see if there's anything that looks fun, and try to talk about it. But that's not really. That's a very random sampling method, right? Yeah, I miss a lot, right?
Well, good luck in your new approach.
Okay. Well, again, thank you, and thank you very much for coming on. It was very nice talking to you. I think we had a really good discussion here. I don't know about you, but I thought it went pretty well.
I did too. I felt a lot more comfortable as we went along. I had a little bit of trepidation going in, but it's a very easy, and you made me feel quite relaxed and able to go on. I don't do this kind of thing. I don't know, very often. I don't go to conferences very much.
Well, thankfully. One of the nice things about I shouldn't say something there's nice about the pandemic, but the nice thing about the pandemic is I was able to actually attend conferences that I wouldn't. I mean, because now instead of paying for the conference and then paying for the airfare and paying for and so forth and so on, right? I mean, it just keeps on building up, right? I mean, I went to a conference last week. It basically cost me $1,500 to go to a $200 conference, and that conference, while it was just online, it was $100, right? So I mean,
okay, yes.
so that made things a lot nicer, but unless you've been going to that particular conference or that over and over again for years, conferences aren't really that much fun. Now, if you've been going for years, then you know all of these people, and then it's just like a party, right?
Yeah.
You go, you watch some you watch some talks, you get some ideas, and you hang out with your friends,
Uh-huh.
and it's a pretty good time, right? And you
Yeah,
come
yeah,
back and you've got all sorts of things that you might be able to do. But if you just go to a conference that you don't know anybody at and
yeah,
hang out, it's just like being in a room with another 50 people,
yeah,
going to
yeah.
another room with another 50 people, and then doing that for 4 or 5 days.
Yeah, really.
That's not so great. Okay, but again, thank you very much. It was great having you on, and I hope you have oh, I want to say a wonderful something, but I mean I don't really know what.
Well,
There are all sorts of things that could be wonderful.
I'm having a wonderful day, and I'm happy that this was it was really went well, I thought. And I thank you again, because like I said, my ideas are pretty far out there, as you've seen, and I don't get a chance to put them out there, but now you did. So thank you so much, Jim.
Okay, well, thank you, Matt. Bye now.
Okay, okay, bye.
Okay.